Bismillahirrahmanirrahim. In this session, we will discuss about space physics for IGCSE and O level students. Uh, Today, we will discuss Earth and solar system. And Earth is a planet of Sun traveling in a nearly circular orbit around the Sun, and the Moon orbits the Earth as a satellite. So, Earth revolves around the Sun, and Moon revolve around the Earth. This is the way that our solar system and our Earth and the Moon belongs to Earth revolve in a path. The motion of the Earth and Moon account for the occurrence of number of natural events. So the motion of Earth, as a result of the motion of the Earth and as a result of the motion of the Moon, number of natural events occurs. As a result of this motion, occurrence of natural events happen. So how day and night happens? So these are caused by the Earth spinning on its axis. So Earth is spinning around the axis as well as it is revolving around the Sun. So it has a dual motion. So spinning at its own axis and revolving around the Sun or orbiting around the Sun about the line through its north and south poles and making one complete revolution every 24 hours. So the Earth completes its spinning around its axis in every 24 hours. Every 24 hours. This revolution, spinning creates day and night. So this creates day for half of the Earth's surface facing the Sun, and the night the other half facing away from the Sun. So the part that faces the Sun has a day, and the part that's away from the Sun is night. So since the Earth spins, so it gradually comes to the Sun and faces the Sun and then passed away. The facing part and the next region appears to the Sun. So in this way that we get the morning, noon, afternoon and evening, and finally the night. So the Earth's rotation on its axis causes the Sun to have an apparently daily journey. So since we are on the Earth, we see that Sun rises from the east and sets in the west. But actually the Sun doesn't revolve. Actually the Earth revolves, and due to the rotation of the Earth, it appears that Sun is revolving while it is still, but due to the rotation of Earth, it happens to the observer on the Earth that the Sun is rising from the east and sets in the west. In the northern hemisphere, in a summer, it rises north of east and sets north of west. So if we see that so this is at the, if this is south, this is east and this is west, this part against the south is the north part. The Sun rises from the east and tracks southern part and sets in the west. So she is here in the northern hemisphere. In the northern hemisphere, most of the Europe and America exist. It happens like this. In a southern region like South Africa, Australia, New Zealand, the shape in that is the southern hemisphere from the Sun will be from the northern region. So it will rise from the east, but it will set in the west through the northern region if the observer is on the southern regions. Here in this picture, the observer, this girl, is on the northern region. So this is the summer, where the path is quite longer. In equinox, say the mediocre level path, while in winter the path is quite short. Each day the sun is so in the northern hemisphere, in summer it rises north of east and sets north of west. In winter it rises and sets south of these points, like this. Each day the sun is highest above the horizon at noon. At noon, it looks like that the sun is at a maximum distance for this observer. So, and directly due south in the northern hemisphere. Directly due south in the northern hemisphere. The observer is on the northern hemisphere, and it looks like that the sun rises from the east and tracing the path from the northern sector and sets in the west. It never observe on the northern to due north. It never see the due north from the northern region, but in a southern region. From the southern region, southern hemisphere, the sun rises from the east and trace through the due north and sets in the west. This is very, very important from the examination point of view. This point is very important. This figure is very important. If the observer is on the northern hemisphere, the sun rises and sets like this. While in a northern region, if the observer is on the southern region, then it rises from the east and trace or due through the northern hemisphere and sets in the west from the other side. So, orbit of the earth. The earth orbits the sun once in approximately 365 days, that is 1 year. So actually the sun orbits the sun, the earth orbits the sun in actually 365 days and 0.25 days. So every 4 years we get a leap year. The path of the earth around the sun is not quite circular. The path around the sun is not quite circular, but it's somewhat elliptical, but takes the form of an ellipse with the sun at one focus, only one focus, and the sun, the earth revolve around the sun in an elliptical path. Figure 6.12 shows the earth in 4 different positions in its orbit. Here this is point A, that is around March 20, and at point A, this is equinox point. From A it moves to June 21. This is the spring region. This is a spring. This is a spring, and earth tilted on axis. So, and earth revolves again, and here comes the summer region. This June to September, this is summer, and from this B point the earth revolves and it comes to 21st December, and from September to December we call this period autumn or fall. From 21st December to March, this is winter. December, January, February are the winter region in the northern hemisphere. This is for the northern hemisphere. This part, this above part of this earth, this half hemisphere, half of the sphere, that is hemisphere, half hemisphere, this upper part of the earth. In the lower part, that is the southern region, where the case is different, is reverse of this. So motion of the moon is a satellite of the earth and travels around it in approximately circular orbit, close to a circular orbit, and approximately takes once a month. The moon revolves around the earth in around 28 days or 29 days, approximately 1 month. The average distance between earth and moon is 400,000 kilometers. The average distance between earth and moon is 400,000 kilometers. The moon also revolves on its own axis in a month. So moon also revolve on its axis in a month, and so always has the same side facing the earth. So we never see the dark side of the moon, since moon reflects the lights of the sun, and that faces the earth. So the path or the face of the moon that observed from the earth is always shiny, but the geometry changes with time, so we see the shiny part of the moon rising and falling. But we never see the dark side of the moon. So we see the moon by reflected sunlight. Moon doesn't have any light, it's a non-luminous object, but it reflects the light of sun. It doesn't produce its own light. Moon does not have an atmosphere. There is no atmosphere on the moon. Why does astronaut walk on the moon in a springy fashion? The moon has a gravitational field due to its mass, but the field strength is only 1/6 of that on Earth. So the gravitational field is 1/6 of the gravitational field on the Earth. Hence, the astronaut who walked on the moon moved in a springy fashion and did not fly off into space. So there is a gravitational field, but the field is low as compared to Earth. So the astronaut walks on the moon in a springy fashion. The phases of moon. The moons appear from the Earth changes during its monthly journey. It has a different phases. So here we see that the sun rays applying, and this is Earth, and from Earth we see the sunlights. So moon as seen from the Earth. So this is the moon motion. So this is the new moon, and from the Earth we see just a very small size on the first day of the moon of any lunar month, and it gradually rises. So at around 3 days or 4 days, the sun size appears like this much. After 7 days, the sun appears like this shape. Afterward, it also grows to this shape, and on 14th of every month, the sun becomes a full moon like this. Then it gradually decreases, and after 7 days from this 14, this is 21 days, here the moon becomes half, and afterward it decreases and disappears, and eventually a new moon rises. So this is the lunar cycle of moon from the earth. Rising and setting of the moon. Like the sun, the moon appears to have a daily trip across the sky. It observed from the earth. This is all happens because of the earth motion and the moon motion from the east. It rises from the east and sets in the west. Again, this is due to the earth rotation on its axis. This happens because the earth is revolving, the moon is revolving. So earth is revolving around a sun and the moon is revolving around the earth. The orbital speed. It is defined as the average speed is equal to total distance, total orbital distance divided by total time. So for the moon moving in a circular orbit around the earth with an average orbital speed v is equal to circumference of orbit, that is 2 pi r. R is the radius of a radial distance of earth between earth and moon, and t is the orbital time period. So test yourself, page 280. The earth is a planet of the sun. Which one of the following statement is not true? The earth orbits the sun once each year. This is true. The earth spins once on its axis every 24 hours. True. The sun completes its spin on its axis in every 24 hours, and as a result a day and night in half of the earth appears everywhere. Day and nights are due to the earth spinning on its axis. True. This is true. D part, at places on earth hemisphere tilted toward the sun. Earth hemisphere, no, it's tilted towards its axis. The day is shorter than the night. No, because the earth tilted on its axis, not an hemisphere. So statement D is incorrect. Question number 2. Taking the average distance of the moon from the earth to be 380,000 kilometers, 380,000 kilometers, and the orbital speed of the moon to be 27 days. Calculate its average orbital speed in kilometers per second. The distance between moon and earth, radial distance, this is an average radial distance between moon and the earth is 380,000 kilometers, and the orbital period of the moon is given as 27 days. Calculates its average orbital speed in kilometers per second. So the distance is average radial distance is 380 kilometers. Orbital path it develops or trace is 2 pi into this radial distance. This is the circumference of this path, that is 2387610.42 kilometer. It means 2.38 or 39 million kilometer. The time it takes 27 days, so that's in second is 27 into 24 into 3600 seconds. So the average orbital speed in kilometers per second. Therefore, the average orbital speed is equal to circumference divided by time taken, and it is obtained as 1.0235 kilometers per second. 2 pi, and this is this orbital distance. So this is the average orbital speed. The solar system, the system consists of one star and 8 planets moving around it in elliptical orbit. Here we have 4 planet that is rocky shape, while this 4 is gaseous shape. So slightly flattened circle. And solar system also includes minor planets. Beside these 4 and these 4, there are some minor planets. These are the minor planets. And asteroids which orbits the sun, and some asteroids. These are smaller planets, or also called asteroids, which orbits the sun. Moon that orbit many of the planets and smaller solar system bodies such as comets and natural sun. Moon that orbit many of the planets. These are the planet that is orbiting the sun. But moon, on every planet, there are moons that orbit the planets in a smaller solar system bodies such as comets and natural satellite. The 4 inner planets, these are the 4: Mercury, Venus, Earth. This is Mercury, Venus, Earth and Mars. These 4 planets are all small and of similar size, solid and rocky. These are all solid and rocky with a layered structure and have a high density. These 4 planets have high density in the rocky layered structure and have a high density. While the outer 4 planets, Jupiter, Saturn, Uranus and Neptune, are much larger and colder and consist mainly of gases. They are gases. Their density is low. These outer planets have many moons and other natural satellites in the form of ring of icy materials. These planets have number of moons, and they are very gaseous type, icy and very cold, very low density. Most of the dwarf planets, the best known of which is Pluto. Pluto is very small size. It's called a dwarf planet. The best known of which is Pluto, orbits the sun at an average distance greater than the Neptune. It orbits the sun the greatest distance. It is very far away from the sun. It takes a very large path around the sun. These are trans-Neptunian objects, TNOs. These Plutos are called TNOs, trans-Neptunian object, TNOs. And together with their satellites, number over 2000. They are generally of very low density and thought to be composed of mixture of rock and ice. They are very small size. The asteroids are pieces of rocks of various sizes which mostly orbit the sun in the asteroid belts. The asteroids are pieces of rocks of various sizes which mostly orbit the Sun in the asteroid belts between Mars and Jupiter. These asteroid belts are basically segregating these 4 planets. So this outer planet of this rocky shape is Mars, and the gaseous one is Jupiter. So between Mars and Jupiter's this asteroid belts exist, and this also orbits around the Sun. And their density is similar to that of this inner planet. These asteroids have similar structure like these 4 inner planets. If they enter the Earth atmosphere, they burn up and fall to Earth as meteors or shooting stars. These asteroid belts, if they appear on Earth, then it appears like a shooting stars or comets or meteors or shooting stars. They burn up and fall to the Earth as meteors or a shooting stars. The largest asteroids, Ceres, is classed as a dwarf planet. Ceres is classed as a dwarf planet. This is also largest asteroid. Ceres is also classed as a dwarf planet. Comets consist of dust embedded in ice made from water and methane, and are sometimes called dirty snowballs. Comets are also called dirty snowballs. Their density is similar to the outer or planet like Jupiter's, Uranus, Neptune's, and they orbit the Sun in a highly elliptical orbit and are much closer to it at some times than other, as shown in figure 6.16. They return to the inner solar system at regular intervals, but in many cases these intervals are so long owing to journey far beyond Pluto they cannot be predicted. So on approaching the comet to the Sun, the dust and gases are blown backward. When they close to the Sun, so this kind of shapes appear. The dust and gases are blown backward by radiation pressure from the Sun, and the comet develops a bright head and long tail pointing away from the Sun, like this, pointing away from the Sun. This is very, very bright, and this tail pointing away from the Sun. One of the most famous is Halley comet, which visits the inner solar system about every 76 years, the last occasion being 1986. The Sun is a star and produces its own light. The Sun is a luminous object. It produces its own light. The planet and our moons are seen from the Earth by reflection of the solar light. So other planets and moons doesn't have any luminous object. These are all non-luminous objects, and it gets the light of Sun and reflect the light of Sun. The elliptical orbit. The planet, dwarf planets and comets, asteroids all orbit the Sun in an elliptical shape. The Sun is at one focus of the ellipse, not the center, as shown in figure 6.16, like this. The orbit of comet. This is the orbit. It comes to the sun, closer to the sun, and then far away. For a comet with a highly elliptical path, the focus is not close to the center of the ellipse. So the focus is quite eccentric. For the approximately circular paths of the planet, the focus can be taken as the center. More than 99% of the total mass of the solar system is concentrated in the sun itself. In a solar system, the sun contains 99% of the total mass of this solar system. So it exerts a very high gravitational attraction. So due to the mass concentration, it has high gravitational attraction that keeps objects such as the planet orbiting around it. Why planet orbit around the sun? Due to high gravitational attraction, and high gravitational attraction by virtue of the higher mass, that is 99% of the total mass of the solar system is concentrated on the sun, such as the planet and orbit around it, and all the planets and meteors and dwarf planets, comets, asteroid belts, all orbits the sun in an elliptical orbit. Gravitational field strength of a planet. What is gravity? Newton proposed that all objects in the universe having mass and attract each other with a force called gravity. The greater the mass of each object and the smaller their distance apart, the greater is the force. Halving the distance, quadruple the force. The force of, if the distance between the object becomes half, then the force of attraction will be, or force of repulsion will be 4 times. For a planet, the gravitational field strength at its surface depends on its mass and is nearly uniform across its surface. So, the planet having higher mass have a higher gravitational field strength. The planet with a lower mass have a lower gravitational field strength, and it is nearly uniform all across the surface of that object or planet. The strength of the gravitational field decreases as the distance from the planet increases. The gravitational field strength decreases as the distance from the planet increases. The travel time, the planet and their moons are visible from Earth only because they reflect light from the sun. The planets and moons are visible from Earth due to the reflection of light from the sun. The outer region of the solar systems are over 5,000 million kilometers from the sun. The outer region of the solar system are over 5,000 million kilometers from the sun, and even light takes time to travel to such distant places.